Hello, this is my presentation video for my ECE6122 lab 6. The task in this project is the same as lab 5, but it requires us to use MPI instead of CUDA to compute a matrix. The most important part of this project is how to spread the whole computation task into different processes and control the communication between processes to generate the final result. First, I would like to talk about how to spread the computation task evenly. I will split the matrix into several rows, and each process only handle one piece of them. For example, if I need to calculate a A times A matrix, then I have 4 cores. Then each core need to calculate 2 rows. Now we have another problem that what if the number of rows is not divisible by the number of cores? Like if I have a 9 times 9 matrix but I have 4 cores, then it's not divisible. What I try to do is try to spread them evenly, which means the first process get an equal size of the matrix, and if there is a remainder, then spread the reminders evenly from the beginning. Like if I have a 9 times 9 matrix but I have 4 cores, then each core gets 2 rows first. Then we have 1 remaining rows. Then I will assign this row to the first core. Here is the code to spread the computation task evenly. So with such calculation, I can spread the computation task evenly on each core, no matter the size of the matrix and number of cores. Second, the second problem of this project is to handle the communication between processes. I need to use MPI method to send or receive message among the process. Here, I introduce the concept of virtual rows. If process have the rows spread from the matrix, which is the computation task that the process have to do, as well as 2 more virtual rows for communications. The virtual rows are used to communicate with other processes. For example, if a process have 2 rows, then it also have 2 virtual rows. Here you can see the 0 and 3 is the virtual row, and 1 and 2 is the matrix row, which is this process need to compute. There are 2 steps. The first step, I call it top-down, because each process need to send its row 2 to next process and receive data on its row 0, which means this process need to send the last row, the row 2, to the row 0 on the process next to it, and it also need to receive data on row 0, which is sent from the previous process. And another step called downtop, which means I need to this process need to send its row 1, the first row of its computation task, to the previous process and receive the data from its next process on its row 3. So by using these mechanisms, each process can get all the information it needed for the calculation. And also I do some experiments to show you the time for different parameters, and you can see here is the result. So that's all. Thank you.